Hey, what's going on guys? Tanmay here for Simple Snippets. Welcome back to another video tutorial on data structures and algorithms, and let's quickly continue with our graph implementation topic. In this video we're going to talk about the update edge operation. Now before we proceed, I'm assuming you guys have already seen the first few videos of the graph implementation. If not, this video is going to be difficult to understand. So for those who are new or have missed any of the videos, please check out this data structures and algorithms playlist. All the videos are in proper order. Make sure you watch the graph data structure videos from theory as well as the implementation. When I say implementation, it means that we are actually writing C++ program to implement the different standard operations in a graph data structure. For example, addition of vertices, addition of edges, updation, deletion, so on and so forth. So we've already done the operation of add vertex, add edge. We also saw the printing of the entire graph that we've basically added. So all this is happening in C++ program. So we are seeing the output on the command prompt. So again, for those who've missed, please check out the previous videos. For those who've already seen that and are waiting for further videos, you're good to go. Things are going to be much more faster to understand moving forward because we've already done some of the implementation, right? Alright, so let's talk about update edge operation. So as the title of the video suggests, as the title of this operation, that is update edge, it means that we want to update a edge. Now, before update edge, quick recap of what we've done so far and the assumptions that we're going to do in this video. So we are going to assume that we already have a graph with 3 vertices, which you can see right now on the screen. And this is how it is going to look like in memory. We are also going to assume that vertice 1, which stands for MH, which is Maharashtra. So our graph is representing states, and the edges basically represent the connectivity between them. And we have also said that our graph is going to be an undirected graph as well as a weighted graph, right? So we are assuming that Maharashtra and Goa, that is GA, is connected. We are assuming that Maharashtra and Madhya Pradesh is connected. So these are certain assumptions that we are already doing, okay? So we are basically saying that we've already added 3 vertices and 2 edges, right? And now we want to update an edge. So what do I mean by updation of edge? So in our specific scenario, we've said that our graph is undirected, but it is weighted, which means that there is a weight on the edge between Maharashtra and Goa. So what is that weight? You can see it is 500, right? So that is the edge object in the edge list, correct? So the weight, which we are assuming is in kilometers, basically let's say the distance between Maharashtra and Goa is 500. So this is the weight. And similarly, the distance between Maharashtra and MP, that is the weight, is 700 kilometers. So when you say update edge operation, you want to update this weight, okay? So let's say while adding these edges between the particular vertices, you make a mistake and you want to now change it. Let's say you made a mistake and now you want to change this 700 to 800. How do you do that? So this is the actual function and this is the whole operation and today's topic. So we are also going to see the working step by step, dry running this entire pseudocode on the left, which you can see is for the update edge operation. Don't get intimidated, this is very easy. We'll go step by step and then we will convert this same pseudocode into C++ program. So second part will be the actual practical side. Okay, so make sure you watch this video till the end. We will go step by step and see what is happening behind the scenes. And once we dry run this entire code, things will be very much clear. Alright, so let's start with update edge by ID. So this is our function name, update edge by ID. So I hope you understood what we want to do. What we want to do is we want to change this weight value. And let's assume you want to change this weight value between Maharashtra and MP. Okay, both of these vertices have their individual respective IDs. So when you say update edge by ID, what we will do, we will pass the 2 IDs, that is from vertex and to vertex. So let's say the from vertex is Maharashtra. So the ID is going to be 1. So let me write from vertex equals to 1. Correct? The next thing is to vertex. So what is the to vertex? It is MP and the ID is 3, right? So we're going to pass 3 over here. The last parameter is the new weight that you want to update. So currently it is 700. Let's assume you want to update it to 800. So you want to change this to 800. So let's say the new weight that you want to update is 800 kilometers. So you pass 800 over here. Alright? Okay. So these are the things that you pass in this function. Now this is our user defined function. So let's go step by step. This is step number 1. So at step number 1, you're doing a check. You say check equals to check if edge exists by ID. Now before you actually make these updates, obviously you need to check whether there is a edge between Maharashtra and MP, right? You need to first check if a edge exists. Only then you can update its weight value. So in case, let's say you wanted to update the edge value between Goa and MP, but currently there is no edge only. So what are you gonna update, right? So that is the very first basic check that you have to do. And if you have seen the previous videos, we've already done this function, that is check if edge exists by ID. Basically what this function does is it takes the IDs of the edges, that is the from vertex and to vertex. Basically you'll pass 1 and 3, and it just checks the edge list of one particular vertex. So it will go into Maharashtra's edge list and it will check in the edge objects whether a edge object with this ID exists or not. So in Maharashtra's vertex, we have this edge list who has 2 edge objects. This is the first edge object which represents this edge, correct? That is 2500 represents the edge object between 1 and 2, that is Maharashtra and Goa. And 3,700 represents the edge object between Maharashtra and MP. So we have one edge object with ID 3, and since we've passed 2 vertex as 3, it would mean that there exists an edge. So this will return true. Okay. Now I'm not going step by step and explaining this user defined function, that is check if edge exists by ID, because that is something that we've done previously. So it will just take up our time. But basically it will return true. Okay. So true value will be returned, and then we will do a if and else check. We will say if check equals to true, it would basically mean that edge exists between 1 and 3, that is Madhya Pradesh and Maharashtra, right? So it would mean that edge exists, correct? Now if it would have returned false, so this is the if block, which is this whole part. But in case if the check value would be false, that is in case if this check if edge exists by ID returned false, then this else part would have been executed, and in that else part we simply print edge between from vertex and to vertex does not exist. Makes sense? Pretty basic. But currently the check value is true because we've passed 1 and 3. 1 is for Maharashtra, 3 is for Madhya Pradesh, MP, and there exists a edge currently with the weight as 700, which we want to actually change, correct? So since this is true, we will go inside the if block, and the first thing is we have to loop. Now the loop starts from 0 to vertices.size. So from 0 to vertices.size. So what is this vertices variable? So this vertices is actually a vector. A vector in simple terms is nothing but a dynamic array. We've already talked about it. And currently in this vector, that is name of this vector is vertices, we have 1, 2 and 3 elements, correct? So from 0 to vertices.size, what is the size of the vertices vector currently? It is 3 because it is holding 3 elements. You can see vertices at 0, vertices at 1 and vertices at 2. So as I said, this is a array. You can consider this as a dynamic array. And when I say dynamic, it means that its size can increase and decrease in the runtime when the program is running. So currently we have 3 vertices, Maharashtra, Goa and MP. Each of them occupy 1 space in the vertices vector. Hence the size currently is 3. So you'll go from 0 to 2. Basically 0, 1 and 3. Right? So you are gonna run this loop 3 times. Okay. So why are we running this loop? So this loop is basically going through all the vertex in this vertices vector, and whenever you find an edge between Maharashtra and MP or MP and Maharashtra, then you make that change of 700 to 800. Now remember, I already said that our graph is a undirected graph, which means if there is a edge between Maharashtra and MP, there is also an edge between MP and Maharashtra, which means there are 2 entries of this 700 value. You can see in the edge object, that is in the edge list of Maharashtra, we have 1 edge object which is 3,700. Similarly, in the edge list, which is this green box of MP, that is Madhya Pradesh, we also have 1 edge object which is 1,700. So 1 comma 700 and 3 comma 700, both these values represent the same edge because it is an undirected graph. So both these 700 values need to change to 800, correct? You can't simply change one particular edge object, that is make this 800 and keep this 700, right? You can't do that. You have to change both of them to 800. So that is why we have to do two changes, and we have to loop through all the vertices first to check out which edge we want to change. Okay? Now how that check happens, that will happen in this loop. So this first loop is for iterating through all the vertices. Okay, let's proceed. Now inside this loop we have a condition. We say if vertices at I dot get state id equal to from vertex then. Okay, let's try to dissect and let's try to understand what this if condition is. Okay, so we are saying if vertices dot at. So remember I said vertices is a vector which comes from the STL library basically. So this at is nothing but an inbuilt function, and it takes one argument which is an integer value, and that integer value is nothing but the index position. So if you say at 0, it will give you the very first element. If you say at 1, it will give the second element, just like an array, right? In an array, what do we have? Let's say array A, you pass the index position, right? Similarly, this is a function, so it is not in square brackets, but it behaves similarly to an array. As I said, it is a dynamic array in simple terms, right? So it has these inbuilt functions like at, and you pass the index position over here, and currently we just said that this loop is going to run from 0 to 2, correct? So let's say the current iteration number is 0. So let's say the I value is equal to 0 currently, because I is going to go from 0 to 3, right? So let's say currently it is 0. So when you say at I, it means you're saying 0. So basically we are targeting the very first vertex in the vertices vector. So we're saying if vertices dot at I dot get state id. Now currently you are pointing to, or currently basically you are at the very first vertex and you are saying get state id. So remember we had a get state id function which we created, which returned the state id of a particular vertex. So currently we are at the very first vertex. What is the state id of this vertex? It is 1. So you'll get 1 over here. So basically we are getting 1 over here, and now we are checking equal to, is it equal to from vertex? What is the from vertex? This from vertex is this variable, remember, that we passed in this function, whose value is 1. You can see it over here. So is 1 equal to 1? Yes. So now we will go inside this if block, and now we are basically at the very first vertex, and that vertex has matched the from vertex, correct? The from vertex id we passed 1, Maharashtra's id is 1, and the very first element in the vertices vector is also 1. That id is also 1, correct? So we've got a match. So we know that one of the vertex out of the two that we have to update is Maharashtra, and we've got that in the very first iteration, correct? I is still 0. So we go inside this if block, and now we have to loop. But this time, what is this second loop, that is inner loop for? This loop, the inner loop, is gonna go through the different edge objects inside the edge list of this Maharashtra vertex. Let me repeat it again. This second loop, the inner loop, is going to loop through the edge list, that is this green box, and it is gonna go one by one from this object to this object, and it will check. What it will check? It will check for this first id. Remember the edge object, that is the edge class, it had the destination vertex and it had the weight. So this destination vertex, that is 2 and 3, is what we are looking for, and it has to match with the 2 vertex, correct? Let's go in the loop and you'll understand it. We say loop id equal to vertices at I. We are still I equals to 0, which means we are still at the very first vertex, dot edge list. Edge list is nothing but this whole green box, and edge list is of type list, remember, which also came from the STL. This is again something that we've already talked about previously. And we say dot begin. When you say begin, it means that the very first element in the edge list. So basically vertices dot at I equals to, or it means that vertice is at 0 because I equals to 0, which is this particular vertex, and inside this vertex we are accessing the edge list. So we are going in this green box, and in this green box we are saying dot begin, which is again a inbuilt or predefined function of the list STL, that is the list object, which basically begins from the very first element inside the edge list. Which element do we have inside this green box? We have the edge object. So we will begin from this first edge object to vertices.at.edgelist.end. So begin is the very first element, end would be the last element, makes sense. So we will go from the first element to the last element. So basically this loop will run 2 times because we have 2 edge objects inside this edge list. Correct? So this loop will run 2 times. Okay? So what happens inside this loop? So inside this loop we have to make a check. What was that check? We say if it, what is it? It is equal to vertices.at.edgelist.begin. So essentially it is the iterator, you can say, which is currently pointing at the very first edge object. So we say if get destination vertex id. So it is currently pointing to this edge object. So when you say get destination vertex id, you are saying it.getDestinationVertexID. So you are gonna get the vertex ID of this edge object. What is the destination vertex ID? It is 2 over here. Correct? So you're gonna get 2 over here. Let me write 2. Is it equal to 2 vertex? What is this 2 vertex? Remember at the very top in the update edge by ID we pass the 2 vertex and it is equal to 3. Right? We've written it over here also. 2 vertex is 3. So is 2 equal to 3? No. So it's not a match. Correct? So this if block, which has 2 statements inside, does not execute, will come at the start of the loop again. And now, as I mentioned, this inner loop will run 2 times. The second time, it will now start pointing the second edge object. Okay? So now it is pointing the second edge object, which is this 3,700. So the loop starts running second time. Again you go inside, you say if it.getDestinationVertexID. So it is currently pointing to the second edge object. When you say get destination vertex ID, this time the vertex ID is 3. So you get 3. Now is it equal to 2 vertex? 2 vertex is still 3. Yes, this time we've got a match. So now you can see that we have basically found the particular edge which represents this edge, that is 3,700. Correct? We found the first edge which is 3,700, and now we are saying it.setWeight. So setWeight is a user defined function which will take the integer value. So okay, it is going to take an integer argument and it is going to set that value to that particular edge object's weight. Okay, so edge object has destination vertex ID as the data member and the weight. So we're going to change the weight and we are going to say new weight. What is new weight? New weight is 800. So 800 is going to be set over here. So this 700 now becomes 800. Okay, let me quickly update it over here. Okay, so you can see this has become 800. Let's update it in this visual diagram also. Alright, so you can see that the first edge object which is inside the edge list of Maharashtra vertex is updated, and it is updated with the new weight 800. But this is still half work done. Why? Because we still have to update the edge object in the Madhya Pradesh vertex also. Right? Only then you can say that this entire single edge has updated to 800. That is, the weight is updated to 800 because it is an undirected graph. So there are 2 edge objects representing the same edge. Correct? So this is where this first loop of course will stop working because, as I said, it runs 2 times. It has already completed its execution 2 times. And this is where the next else if works. So this if is inside this loop. This else if is also inside this loop. So we are still running in the first iteration of the outer loop. Okay. So I is still 0 for the outer loop. Now this if is done. So consider this if block as the if block for one particular vertex, and this else if block is for the second vertex, because as I said, when you want to change the weight of a particular edge, in our case, in this particular use case of our implementation, we have to make two changes in two different vertices because two vertices are connected by a single edge and both of those vertices have that edge object in their edge list with that particular weight value which has to be updated, correct? So this second else if is for Madhya Pradesh. How so? Let's figure it out. So the first if is done. In the else if we say if vertices at get state ID, so we have I equals to still equals to 0. So vertices at 0 is going to be the first vertex Maharashtra, the state ID is 1. So is 1 equal to 2 vertex. What is 2 vertex? 2 vertex that we've passed over here is 3, correct? 2 vertex is 3. This is not going to change. 1 and 3 are not going to change. Is 1 equal to 3? No. So this else if did not execute, which means you did not go inside, we did not go over here, we did not go over here. All this was skipped. You come outside the else if, we have nothing over here. So you'll go start of the outer for loop. Now this I value becomes 1 because remember we are saying loop from 0 to vertice.size. We just did one single iteration. So now I value becomes 1. Okay. And then you again go inside this outer loop. Okay. So again starting this outer loop, we have if vertice dot at 1. Correct? Now I has become 1. Dot get state ID. So vertice at 1 is what? It is Goa, whose ID is 2. So the ID that we get is 2. Is it equal to from vertex? From vertex is what? From vertex is 1 that we've passed over here. Is 2 equal to 1? No. So this first entire if block will not be executed. You will proceed. You'll go to the else if. You'll say vertices dot at again. I is 1. So at 1 is nothing but Goa. And you say dot get state ID. Goa's ID is 2. So you'll get again 2 over here. Is it equal to 2 vertex? 2 vertex is 3. You can see over here. Is 2 equal to 3? No. So again this entire else if is not executed. Now this both if and else if did not get executed because it makes sense. Both of if and else if were trying to access Goa's ID, but we are not interested in Goa because we want to update a edge between Maharashtra and MP. So Goa is not concerned, right? So this vertex is completely ignored. Again you come at the end of the outer loop, you come at the start of the outer loop, and now I becomes 2. So this is the third iteration and the last iteration. So I becomes 2 because we started from 0. So 0, 1 and 2 3 times. This is the last iteration. We go inside, we say if vertice dot at I is 2. So vertice at 2 is nothing but this last vertex, which is Madhya Pradesh, which we actually want to change, right? So over here you get the ID of Madhya Pradesh, right? You say get state ID, you get 3. Is it equal to from vertex? From vertex is 1. No. So this first if block was executed for Maharashtra, right? Which means currently it is not going to execute for Madhya Pradesh. You will go in the else if block. Over here we are checking if vertice dot at, again it is at 2, which is nothing but MP's vertex dot get state ID. What do you get as state ID? You get 3. Is it equal to 2 vertex? Now we are going to get a match because 2 vertex is 3. So the first if we were matching with the from vertex, the second else if we are matching with the 2 vertex because we want to make 2 changes, remember? So when you get this match, again the loop is going to do the same thing. It is going to say IT equals to vertices at I we just said is 2. So vertices at 2 dot edge list. So IT this time, let me write it over here, is basically trying to access the edge list, and we say edge list dot begin. So in this edge list we have only one object, which means that this inner loop is going to only run one time. So edge list dot begin to edge list dot end, we only have one element in this edge list, that is one edge object. So we go inside this loop only one time. We say if it dot get destination vertex ID. So it is currently pointing to the very first edge object, which is 1,700. So when you say get destination vertex ID, the destination vertex ID is 1 over here. So we say is 1 equal to, and you match it with from vertex. From vertex is also 1, correct? So remember in this first if block in the inner loop, in the inner if condition, we were matching it with 2 vertex. Over here we are matching it with from vertex. Okay, it's the exact opposite. So when you get a match, 1 is matching with 1, we say set weight, that is the new weight that we have passed, which is 800. This is not going to change. So 800 is going to be written over here at this place, and visually it is going to be over here. So let's make that change. So 800 is written over here by saying set weight, and then you break out of this entire control statement. And of course, since this loop is also going to run only one time, so you exit outside this else if. You come at the end of the outer for loop, you go at the start, and remember I is equal to 2. We were going to run from 0 to 2, which means that this loop is also done iterating through all the vertices. We started from Maharashtra, we went to Goa, we came to Madhya Pradesh. We only have 3 vertices, so 3 times this loop is gonna run. After that, you'll come outside and you'll say print, and you'll print out on the command prompt, you say edge weight updated successfully. And if you observe the graph as well as what happens behind the scenes in the memory structure, both these edge objects have been updated, which means now 700 can be updated to 800. The weight of the edge has been updated successfully, which means our update edge operation is completed. So I hope this entire pseudocode step-by-step dry running makes sense. If you still have any queries, you can pause this video and dry run this pseudocode. You take a pencil and paper and try to go step by step and write down all the values of all the individual variables, what happens at every scene. Take your time and try to dry run it and understand it even further. And now let's actually switch to the C++ IDE. Let's convert this entire pseudocode into working code and see our code live in action and complete the practical side. Okay, so I've opened up our Dev C++ IDE. We've already typed quite a lot of code. I'm guessing you guys have also done it if you followed the previous videos. If not, I will share the link to this entire code. You guys can copy paste it for reference purpose, but I recommend that you at least type it once. I've pretty much said that every time in all the videos. And yeah, in the graph class, we will have to add a new function. So let's do it above print graph. Print graph is something that we did previously. Okay, so I'm gonna copy paste this code. I've already written it. I don't want to waste your time. We've already dry run the pseudocode. It's pretty much gonna be exactly line to line the same. So this is the entire code. This is our function name, void update edge by ID. You pass the from vertex to vertex and the new weight, just like we did in the pseudocode. You do the first check. If the check is true, you run a for loop. You go from 0 till the vertices.size, correct? Inside this for loop, you have if block and you also have a else if block, right? So the first if block is for one particular vertex, the else if block is for the other vertex between which the edge exists. You have to do the updation 2 times in each of the individual vertices edge list edge object, correct? And then you simply print out edge weight updated successfully. And in case if you have entered from vertex and to vertex of 2 vertices between which the edge does not exist, then you print the else part. You say edge between that particular state name and the particular get vertex by ID to vertex does not exist. So this is just a fancy way of printing the entire name and ID and saying that edge between the two does not exist. You can simply print out edge between 2 vertex and from vertex does not exist, but I have made it a little fancier. Okay, let's save this. We also have to create this set weight function, right? So this set weight will be function inside the edge object. So if you scroll up to our edge object in the class edge, you can see we have a function set weight which takes the weight in an integer variable and it assigns it to the weight data member. Remember, the edge class has 2 data members, destination vertex ID and weight, correct? So I think we are pretty much good to go. Just scroll down to the main function. In the main function, we've done a menu driven program. I'm guessing you guys already know this. So the update edge operation is option number 5. So let's scroll down to case 5 in the switch case. This is where update edge operation happens. What will happen here is simply we will say enter the ID of source vertex, that is the source state. You get ID 1. Then you get ID 2, which is destination vertex. You also get the updated weight, right? You take it from the user W and you call the function update edge by ID, which we just created over here on the top. And if you're wondering what is ID 1, ID 2, W, these are nothing but variables that we have created in the main function. You can say ID 1, ID 2, W, right? And this update edge by ID is just something that we created over here. So let's save this. Hopefully everything works fine. You have your code, or you can check out this entire code on our official website. You can find the link in the video description. Let's try to compile and run. Hopefully things should work fine. Okay, so things seem to be working fine. And let's try to copy the same example that we saw on our blackboard. So first we will of course have to add some vertices, because right now this program ran for the first time. It is blank. We don't have anything inside the graph. That is, we don't have any vertex, we don't have any edges. So option number 1 is for add vertex, which we've done in the previous tutorials. So that code is still working. I'm gonna hit option 1, enter state ID. Let's say it is 1. What is state name? MH for Maharashtra. And you can see vertex added successfully. Similarly, I'll add the other 2 vertices also, that is Goa and Madhya Pradesh. So option 1, then state ID 2, name GA for Goa. Again option 1 for Madhya Pradesh, so state ID 3, state name MP. Alright, so 3 vertices have been added successfully. If you want to see the vertices, we have the print graph operation, which is option 9. So hit option 9. There you go, Maharashtra, Goa and MP with their individual empty edge lists, because currently we don't have any edges. So let's add edges between Maharashtra and Goa and Maharashtra and MP. So that is option number 4. Enter the ID of source vertex, which is 1 for Maharashtra. Enter ID of destination vertex 2 for Goa, and enter the weight. So let's say this is 500 kilometers, right? Alright, edge between 1 and 2 added successfully. Similarly, I'll add an edge between Maharashtra, which is ID 1, and ID 3 is for MP. The edge weight is 700 initially. Okay, when you hit enter, you can see edge between 1 and 3 added successfully. And now if you print graph, that is option 9, you can see Maharashtra has 2 edges. So Maharashtra is connected with Goa. Maharashtra is also connected with MP. Similarly, Goa is connected with Maharashtra, of course, because it is an undirected graph, and MP is also connected with Maharashtra. Now, as I mentioned, we want to change this 700 to 800 or any other value that you want, correct? So that is where update edge happens, which is option 5. So let's hit option 5. So you can see update edge operation, enter ID of source vertex. Let's say it is Maharashtra. Now you can also give this as Madhya Pradesh's ID, okay? Because it is an undirected graph, the source and destination can also be destination and source in this particular scenario, okay? So if I say Maharashtra's ID 1 and MP is 3, and now it is asking for enter the updated weight. So let's say instead of 700, what we want is 900. When I hit enter, you can see weight edge, that is edge weight updated successfully. So let's see if it is actually updated, and to confirm we can say print graph, that is option 9. When you hit enter, there you go guys, you can see in Maharashtra's edge list, Maharashtra is connected with MP, that is 3, but now the edge value is 900. Similarly, MP 3 is connected to 1, that is the edge object has destination vertex ID as 1, but now the weight is 900, which means that updation happened properly and correctly. So this means we have implemented and done with the coding part of update edge operation practically as well, and I hope you've understood the entire working as well as the implementation side. Okay, so I'm gonna wrap up this video over here. I know these videos are a little lengthy, but step by step going through the different operations and pseudocode lines, and also visually trying to see what is happening behind the scenes makes us understand even better. So I'm guessing you guys have a good idea. As I mentioned earlier, you guys can access the entire code in the video description. If you've liked this video, if you've watched this video so far, please give this video a thumbs up. Let me know in the comments how this video was. Do share it with your friends, and I'll see you guys in the next one where we take on some other graph operation. Thanks for watching. See you in the next one. Peace.